Hey, what's up, Grease Monkeys? Mark Joy here. Just want to do a quick live video. Try to do like a 10-minute series here and try to go through some topics that I have been getting traction on. So mostly, which is avionics right now. But today, just wanted to go through the basics of electricity for aircraft mechanics. Really, the stuff that you're going to use. Maybe not on a day-to-day basis, but just generally like the biggest things that you're going to see compared to like all of the really complex theory that you might get in like in a Part 147 school. So hope you enjoy. Hope this goes all right. It's been a while since I've gone live on YouTube. Probably been at least a year or so, just on a different topic. But anyway, I got some slides here for you with a bunch of different info. So hopefully this is about 10 minutes. So just wanted to roll through it here, give it a go. All right, I'm getting ahead of myself here. So mastering the basics, electrical theory, every aircraft technician should know, must know. And like I said, I want to do a 10 video series and pull this from the ACS, the Aircrew Certification Standards from the FAA. So this is going to be stuff from what you would see based on the A&P oral and practical test. So this is the electrical section in, I believe this is in the general section. So, so like I said, just want to do the basics, scratch the surface of very basics of electricity here, and get into what you'll use 80% of the time at work. And especially if you're an avionics tech, this is going to be maybe like what you use on a daily basis, or like if you're checking out a system, this is going to be kind of the main thing that you're going to be getting into. So I've got some examples here of what you'll actually use in aviation. So aside from just like a, I don't know, like a physics or like a chemistry class on electricity and electrons and atoms and all that good stuff. So before we jump in here, just wanted to mention that I have a free A&P Quick Start Guide. If anybody is interested in downloading that, wanted to offer it to you as a gift to you for checking out this live stream. Doesn't look like anyone is on right now, but yeah, this will be recorded and available up on the channel after we're finished today. So anyway, that's the A&P Quick Start Guide is for people who are completely new to the A&P or like aircraft in general or aviation in general. For military people who are transitioning to the civilian side or wanted to get more information on that. And then people who are working as technicians already, so maybe as like at an MRO, but you're not certificated yet. So this guide is going to explain the process of becoming a certificated mechanic for you. So link is in the description down below. Check that out. Hope it helps you out. All right, so the first of the topics I wanted to talk about were understanding voltage, current, and resistance. So these are the three, like the core three sort of elements of electricity, like basic electricity. And the first one is voltage. So that's going to be an electrical potential or source. So in my handy picture over here, I've got a picture of a battery. So like that is going to be a common source where there's like a chemical reaction that's happening that's generating electrons that have like potential to flow through conductors. So we'll kind of get into that later here, so hopefully not jumping too far ahead of myself. And then like before we get even further, you can kind of think of electricity as like a water system. Like you turn on a hose and you've got water that's there, that's pressurized and is just available to go wherever it goes. And you connect a hose or many hoses, and I don't know, so you put a sprinkler head on or like a nozzle on, and you can control the flow depending on how big the opening is. So you can kind of think of it in terms of like of connecting a hose to your water source. So anyway, voltage is going to be that potential, like the source where you're turning the water on or off. And the unit for voltage voltage is volts, and is commonly used with the letter V. You'll also see the letter E as in echo, representing voltage. So a couple of different ways that can be shown. The second of the core three is going to be current. So that's actually the flow of the electrons through the system. So again, talking about a battery as like a source of electrons. You can kind of think of it as like these excess electrons who are looking for a state of balance. So like you think of atoms where there's a proton and a neutron and an electron. If things are out of balance or there are excess electrons, they're going to want to jump to find a balance between proton and electron. So in the picture here, you can see the little circles here as they're jumping. So like this would be, you could think of this as a wire, and in reality, electrons flow from negative to positive. And so you can see like the little circles here are representing the electrons jumping through the different atoms in the conductor as they pass from negative back to positive in the battery. So the unit for electrons is amperes, which is represented by the letter A in equations. So current is like the flow of like thinking about water is the flow of the water through your hose or whatever you got connected up to your water system. So the third one here is resistance, which is going to be loads in the system. So in an electrical system, the idea is to have things connected to it so that you can harness the power of the electricity to power things like lights, or whatever else it might be in the system. So resistance is going to be a load, and that's going to resist the flow of the electrons. So you can kind of think of it as like kinking the hose, and it will kind of slow down the flow of the water through the hose. So that's kind of like a way you can picture it. And the units for resistance is going to be ohms, and here's the Greek symbol ohm for ohms. And then just a note about resistance here too. Conductors or wiring provide a path for electrons to flow with a minimum resistance, but there's still some amount of resistance that the conductors are causing. So like you use wire to connect different loads or different components in the system. The wire induces a certain amount of resistance, but it's very minimal. So just wanted to put that in a note here as a reminder. Okay, so those are the core three sort of elements of electrical systems that you are going to be dealing with out there when you're actually working on aircraft. So voltage, current, and resistance. All right, and then the relationship between those three, the most important one that you're going to be coming across pretty much all the time is just going to be what's called Ohm's Law. So Ohm's Law says that voltage equals current times resistance. So you can kind of think of this equation going back to general mathematics. So as you either increase the current or the resistance of the system, the voltage is also going to increase, but generally you're not going to be changing the voltage of the system. Like the voltage is going to be fixed. So down here you can see the different ways that you can break down the equation. So I would be V divided by R, and R would be V divided by I. So that's kind of the three ways that the equation is presented. So that's just kind of demonstrates the relationship between the voltage and the current and the resistance of electrical systems. All right, so some real-world examples in aircraft systems that you'll see. So voltage sources, chemical sources are going to be batteries. So that would be like your main batteries of the system, magnetic or electromagnetic sources, which would be generators or alternators. So those are going to be harnessing like spinning components, magnetic or electromagnetic, to create electricity using magnets or electromagnets. And without getting too far into that, I think that could be a separate presentation to kind of get into how those work. But in electricity, you can harness magnetism or electromagnetism to create flow of electrons. You can also use heat to create voltage. So in thermocouples, those are components that will generate current if heat is induced. So you can think of like temperature sensors that will produce a current and will like make an instrument move based on the amount of heat that's being like induced into the thermocouple itself. So it's like a device that generates electricity due to heat. And then last here, I have solar panels, which obviously use light to generate electricity, and maybe not used super commonly in aircraft. But I do know that there are some aircraft out there that are solar powered. So just wanted to put that in here as another possible voltage source for you. So yeah, those are voltage sources. And then sources of load would be avionics as the first one here. Control of other systems, so like using electrical systems or electrical components rather to drive other systems. So maybe it's like a servo motor to actuate a control surface, or like a servo tab or something like that. Lighting, so aircraft lights, like position lights or strobe lights, that kind of thing, or like interior lighting. Anti-ice or de-ice systems, so like pitot-static system heat, or like de-ice boots that might be out on the leading edge of a wing or something like that, where they're electrically heated. And then there are obviously many more that are not listed here, but just kind of to give a base of ideas of like common electrical components that are used in aircraft. So those are kind of things that you can think of as real world examples in aircraft systems. All right, and then one thing that's used less commonly would be the power equation. So, but at least wanted to have it up here just in case you come across it. But Joule's law is power equals voltage times current. It can also be written as P equals I squared R. And mainly what I've come across in my journeys in aircraft maintenance and avionics has been in like radio frequencies. So RF is radio frequency. So that would be like radio systems, and talking about like signal loss due to like length of coaxial cables. Thinking about like the coaxial cable that connects like a radio to an antenna, something along those lines, and that's measured in decibels. So dB is decibels, but yeah, power loss is like when I think of using that in a practical way in aviation, I think most commonly I've come across it in like calculating the size of a coax cable that you would need to use in a radio or any sort of RF system. So that's one case where you might need to use it. All right, so that's all for electrical power. So I think kind of my last note is you can kind of think of that as as like horsepower is kind of like the thing that I would think of that as an equivalent to. All right, and then practical applications for aircraft maintenance using our basics of electricity here. The main thing that you'll be using this for is going to be troubleshooting. So that's like 80% of what you're going to be using electrical theory for, at least in my opinion and my experiences. Um, so yeah. So the first thing I wanted to say here was that you're going to be using or working off of electrical diagrams to do any sort of troubleshooting, kind of like understand what the system is doing and all of the components in the system, and just sort of like identify everything that's in line with the problem that you're coming across. And then taking measurements, you're going to be using a multimeter most commonly to take measurements in the electrical system to isolate the problems. So the multimeter is going to be your most useful tool there. So if you've never used a multimeter, here's a picture of one. So multimeter is going to have two leads. You've got a red and a black one. So the black one will go to the common plug or ground, and then the red one would go to the positive side. So that's kind of what you got going on there. And then the switch here, you can select the different functions of it. So we talked about voltage and current and resistance. So the multimeter is gonna be able to measure that in the electrical system that you're gonna be working on. So more specifically on that, in my two diagrams that I have over here on this side, I'll just run through kind of like a brief situation where you're going to be kind of troubleshooting something that would just be like a really simple example. So to measure resistance in the system, the aircraft power will need to be off, and you're going to be using the ohm meter setting on the multimeter. And so kind of like in a nutshell, what this is going to be doing is sending a small amount of current through the system that you attach the leads to. And so I don't know if I said the leads are these black and red cables that connect to the multimeter, and there's like little metallic probes at the end to tap into the electrical system that you're working on. So anyway, aircraft power needs to be off, and then you're going to measure across electrical components, so also known as in parallel. So the kind of the two lines that I have drawn up here, so you can kind of think as across a component. So this right here is would be like a fuse, and so you would put your black lead on one side and the red lead on the other. So this is measuring in parallel. And then another note that I have here specifically is when you're using an ohm meter, the component will need to be isolated from the circuit. So like if you were to measure this as it is right now, it's going to be picking up the resistance from the entire system, ignoring the break here. So what you would do is disconnect the positive side of the battery here, and then you would disconnect the other, this is a switch, so you would disconnect this end of the switch, and you would be measuring the resistance of this fuse here to say test it, to check to see if the fuse was blown. So so maybe that, like, visually you could see that the fuse is blown, but just to demonstrate the purpose of how you would measure the resistance of the fuse here, you would measure it in parallel. So those are kind of the main notes about using an ohm meter. And I would say the ohm meter is probably what I have used most often to troubleshoot systems, is also good to make sure that that electrical connectors are pinned correctly, like the pins are located in the right spot in the connector. And so like in that case, the resistance is going to be very, very, very low, but you're just making sure that there's continuity, or what you would call continuity. So making sure that there are no breaks in the system. So So I guess what I'm saying is that like if I wanted to make sure that that there was continuity of this entire system, I would disconnect the two leads on the battery, and then I would take the measurement here where this my red lead is, and then I would do it on the other side of this light bulb here, or I think more accurately would be like the other side of the connector here to the battery. So like you would be making sure that there's continuity between all of the system here. So like if there isn't an infinite amount of resistance, that would mean that there is a break in the system. But you could kind of go through and calculate the resistance of the different components here, and like you would know what to expect the resistance of the system to be. So so that's maybe not exactly practical, but I just wanted to say that like emphasize that most commonly you would to test for continuity, like you would disconnect connectors at either end of the component and make sure that there was continuity in the wires. All right, so checking for voltage, you would set your multimeter to the voltmeter setting, and there will more often than not be a DC and AC setting. So if you're working on a DC system, you would select the DC function. If you're working on an AC system, you would work on a you would set it to the AC function, and power to the system needs to be turned on. And then like measuring resistance, you're going to measure in parallel, and so that's going to measure what we would call a voltage drop, and I'll kind of like walk through what that would look like over here as well. And then I also wanted to note that polarity matters. So so on this side, if my red and black probes were reversed, and say this was a 12-volt system, the multimeter would show negative 12 volts. Like if I were to just put the black side of the meter on just the negative side. So so the polarity matters. So it's your multimeter is going to show positive or negative if the leads are reversed. But kind of talking about voltage drops. So if I wanted to know what the voltage of the system was at this fuse, for example, I would put my my leads here. Power would be on the system, and then back to whatever to our Ohms Law equation. If we didn't know what the voltage drop was across this fuse, we would take this measurement here, and you would be able to see what the like what amount of voltage this fuse was consuming. So like each of these components in the system are also going to have like a certain amount of voltage that they are consuming. So so like at this point, you would see 12 volts of potential available if this was a 12-volt battery. And then like as you go further down, depending on what the resistance and current is, the voltage drop is going to vary based on like what the resistance is. And then I think my last kind of note about this as well is for measuring voltage. One other common thing that you would do is measure the voltage at like at a connector. So let's say we had an electrical connector that was hooked up to this light bulb over here. Like we would disconnect the connector and turn on power, and you would set your red lead here, and then you would connect the other lead to the aircraft ground, so like a bare metal part on the airframe. And so like with reference to ground, you would be looking to see whatever the expected voltage was at this point. So like if you were expecting 12 volts here, and you wanted to make sure that there was like power was on and available here, you would check for you would check for 12 volts. So like red probe would go here, and then your black probe would go to the airframe ground. So like your your black lead is essentially creating the path back to ground for your voltmeter to register. All right, and then last but not least here, to measure current, power has to be on again, and you're going to use the ammeter setting, and you would have to measure this in series with a component. So to measure the voltage, or sorry, measure the current, you would have to break the system open and like insert your leads into this system. So let's say we had this break in the line here. You would just, to measure the current of the system, you would put your red lead on one end, and you'd probably use like an alligator clip just so it stays hooked on. But hook the red lead on one end, and then the black lead on the other, and so that completes the circuit. And then your multimeter is going to register the amount of current in the system at that point. And then one thing to note is that can sometimes be dangerous if the current is high enough. So you just want to make sure that you're not like touching bare wires, and then this can also like open you up for damage to your multimeter. So I wanted to throw that out there as well. Different multimeters will be rated for different amounts of current. So it's another thing to keep in mind. All right, and then safety considerations for electrical systems. Just generally personal protective equipment, PPE. Like if you're working on like a battery, for example, like you would want to make sure that you're wearing safety glasses or a face shield so you're not getting battery acid splashed up into your eyeballs. And wear gloves, protective gloves, so like rubber gloves or insulated gloves, depending on what system you might be working on. So those are two kind of like common pieces of PPE, and maybe even like an apron if you're working with batteries, like open batteries. And then lockout, tagout procedures. So if you need to, let's say you need to work on an electrical system, and so you've got a component removed or connector removed or something, make sure that you follow the aircraft maintenance manual, and it's more than likely going to be that you need to pull a circuit breaker for that system so that there's no risk of injuring another person who's working on the system. So like you get a red collar to put on up on the circuit breaker so that no one can push it in, and they can clearly see that you don't want anyone to turn on power to that system specifically. But it's also saying that you can put power on the rest of the system. You just want to make sure that system is like isolated from the rest of the aircraft in case of other people are working on it. And then another big one that you want to think about too is like if you need to apply power for any reason to the aircraft, and let's say it's like a big jet or something where there are a bunch of people out there doing things. It's a good practice to kind of like walk around and check with everyone that's working on it and ask them if it's okay to put power on. Ideally, like they're going to, if they need circuit breakers pulled for the system that they're working on, it's not going to affect them, but you just want to double check as a courtesy and like an extra safety measure to make sure that it's okay with other technicians that are working on whatever they're working on, that you can power on the aircraft. And then you just, before you actually turn power on, you want to announce, hey, everyone who is working on Alpha Bravo Charlie 1 2 3, power coming on. You would just yell that out the door just to give people a heads up that you're turning on power. So those are kind of like basic safety measures that you can take when you're turning power on and off. And then for grounding and bonding, you generally want to make sure that the aircraft is grounded when it's in the hangar for maintenance to like dissipate any static buildup that might happen uh, in the hangar. So I don't know, people are I don't know, doing something to the exterior, or I don't know, welding or something. Just want to make sure that the aircraft is grounded, or like working on the fuel system, whatever that might be. Just like grounding the aircraft to an earth ground is a good safety measure to prevent static discharge. Um, so yeah, that's a good one to note here. And then just like generally, the reason that things are grounded, like components are grounded to the airframe, is to make sure that the like if there's a short or something, the electrons are going to go to the shortest path possible, so back to the aircraft ground, instead of um, like shocking someone, and also to complete the circuit. So basically, just to make sure that everything has a common ground, a common electrical ground to the airframe itself. All right, and then lastly, for tool safety, just make sure you use the correct tools for electrical work. So like if you're doing terminations, or like crimping contacts or something like that, you want to make sure that you're using the proper tools. So this could be like mil-spec tools, crimpers, or anything like that. And then also make sure that they're calibrated. So like if you're working with precision tools on an electrical system, make sure that they're calibrated and that you're using the correct tool per the manufacturer specs, or per the aircraft maintenance manual. And then if you're like working on a live circuit for some reason, make sure you use insulated tools to protect yourself. All right, so that pretty much wraps it up here, just to kind of go back over things quickly. I think I'm well over 10 minutes here, but yeah, just to kind of go over this. The core three of electrical theory are voltage, current, and resistance. Ohm's law is going to be E equals IR, or V equals I times R. Common voltage and electrical sources, remember like batteries and generators, or magnetic or electromagnetic, solar panels, thermocouples. And then load sources would be like avionics, and power going out to any other kind of components that are used to actuate different systems. And then Joule's law for power. Power equals voltage times the current. And then mainly we're using this electrical theory for troubleshooting. Like that's the biggest thing that like going through the A&P process and learning all about electricity. Like the main thing that you're going to be using it for is troubleshooting. All right. Just to see, it looks like there is one person on, which I'm very surprised by. And maybe my YouTube studio is lagging, but was definitely not expecting anyone to be watching this while I was live. But if anybody's on and you got a question, please throw it in the chat, and I'll get to it right now. And if that's not real and my system is just lagging here, that's totally fine. And you come back and watch this on the recording. Just make sure you put your questions in the comments, and I'll get to them afterward. And then also wanted to mention that I have an A&P quick start guide, which is free. The link is in the description down below. So like if you're looking to get your A&P and you aren't really sure what the process is, and like if you're in the military, you want to pop over to the civilian side, or if you're kind of working as a tech right now, maybe at an MRO, but you don't have your A&P yet and you are thinking about getting it, this guide that I have will walk you through the entire FAA process. So just wanted to mention that as we kind of wrap up here. So all right, yeah, that's all I have for today. Again, this is going to be video number 1 of 9 that I kind of wanted to do in the live series here. So going to be kind of like following the the topic of electricity and avionics, just because that's kind of what I'm seeing interest from people. But if you watch this video and there's something else that you want to see, just let me know and I'll try to cover it up here. So yeah. So anyway, hope this was helpful for everyone, and yeah, hope the aviation content's helpful for everyone. But thanks for jumping on. If you jumped on here, really appreciate it. And yeah, you will see me tomorrow. Also, my goal is to be on here for the next 5 days in a row, and then take a little break, and then come back 5 more days after that. So anyway, thanks everyone. We'll see you later.